We'll now look at some additional examples involving radicals. Our first example shows 4 parts. Let's begin with part A. Part A asks us to simplify the expression 1 divided by the square root of x. The problem is that in order for an expression to be simplified, if it has a radical, we cannot have a radical in the denominator of the fraction. So we want to look at some techniques here for being sure that we can remove the radical from the denominator of a fraction and finish simplifying the problem. Typically, we do that by using multiplication. So if our problem is 1 divided by the square root of x, we can multiply the denominator of the fraction by the square root of x. If we multiply the denominator by the square root of x, we also need to multiply the numerator by the square root of x. We must multiply by the same thing on the top as we do on the bottom. The reason that we choose to multiply by the square root of x is because that causes the denominator to lose the radical. If I take the square root of x and I multiply it by the square root of x, I end up getting the square root of x squared. If I multiply on the top 1 times the square root of x, I get the square root of x. Remember that there is an understood 2 here as well on the outside for the square root. And so when we take the square root of something that is squared, then we end up simply getting x. The numerator stays as the square root of x. So our expression simplifies to the square root of x divided by x. Let's look at part B. For part B, we're going to begin by breaking up the radical so that we have a 5th root on the top. So we'll have the 5th root of negative 4x to the 6th on the top. And we're going to have a 5th root of 8y squared in the denominator. Now, keep in mind that it would be easiest if we had powers of 5 in the denominator of the fraction. So let's look at our denominator right now. The 8 we know could be written as 2 to the 3rd, and we have a y squared. Now I'm not making any changes to the top, I'm simply going to rewrite it. So when we decide what to multiply by, we want to multiply by terms that are going to create a 5th power, which means that for the 2, we need 2 more of those. We already have 3, we need 2 more to make the total 5. For the y squared, we need an additional 3 y terms. 2 plus 3 would make the 5 that we want. And so we are going to multiply the top and the bottom of this fraction by this expression, the 5th root of 2 squared times y to the 3rd. So let's look at what that does on the top. So on the top, I'm going to combine the 2 radicals. I have a negative 4 and I have a 2 squared. So negative 4 times 2 squared, which is also 4, is going to give me negative 16. X to the 6th, y to the 3rd. And in the denominator, we're going to have 2 to the 3rd times 2 squared. Our bases are alike, so we'll add those exponents, so it'll become 2 to the 5th. And the same thing on the y's. Y squared times y to the 3rd becomes y to the 5th. So this allows us to simplify the bottom part very easily. Because when we take the 5th root of 2 to the 5th, we simply get 2. And when we take the 5th root of y to the 5th, we get y. And so the denominator is now simplified with no radical in it, and we only need to work on the top now. All right, so let's do this. Let's break up the top into groups of 5 wherever possible. Now this negative 16, I'm going to rewrite as negative 1 times 16. That takes the negative and separates it from the number. The x to the 6th, I'm going to write as an x to the 5th and an x to the 1st. That still keeps the 6, but it breaks up an x to the 5th term that we can use with this 5 on the outside. And the y to the 3rd, I'm simply going to leave alone. Okay, so what do we know? We know that the 5th root, an odd root of a negative 1, will simply be a negative 1. So that negative is going to come outside as a negative 1. The 5th root of 16, I cannot take the 5th root of 16. There is no power of any number that would equal 16 when raised to the 5th power. So I'm going to leave the 16 where it's at. The 5th root of x to the 5th is going to be an x. So I'm going to pull that out to the front as an x. The 5th root of x to the 1st, I cannot do that, so I'm just going to leave it underneath. The 5th root of y to the 3rd, I cannot simplify that any further, and I'll leave that underneath. And so our final answer will be, and I'm just going to clean it up just a little bit here, will be negative x times the 5th root of 16xy cubed over 2y. Part C of the expression, we have 4 divided by the square root of 7 plus the square root of 3. Remember that in a situation like this, in order to remove the radicals from the denominator of the fraction, we multiply by what's called the conjugate. And the conjugate would have the same terms as what we have in the denominator, so still a square root of 7 and a square root of 3, but it'll have a different sign in the middle. It'll have a subtraction. Remember that we need to multiply top and bottom by the same thing. So let me fix that real quick. It needs to be a minus there, just like it was on the bottom. All right, so let's do our multiplication here. So when we multiply these two expressions together, we're going to do FOIL method to multiply those together. So we're going to multiply first times first. Square root of 7 times square root of 7 is the same thing as the square root of 7 squared. Then we're going to multiply the square root of 7 times the negative square root of 3, which would be negative square root of 21. These are our outside terms. Then we're going to multiply our inside terms together, which would be these two. That would be a positive square root of 21. And then we're going to multiply our last terms together. So that would be a negative square root of 3 squared. For the numerator, I'm just going to leave it for right now as 4 times the square root of 7 minus the square root of 3. And we'll come back and simplify it later if we think it's going to help. So again, leaving the top part as it is. Let's see what happens on the bottom. The square root of 7 squared becomes 7. These terms will cancel out because we have a positive and a negative. The square root of 3 squared becomes 3. And so we have 4 times the square root of 7 minus the square root of 3 divided by 4, and we can see now that these 4's will cancel, leaving me a final answer of the square root of 7 minus the square root of 3. And the last part of this problem we have a similar dilemma with the square root of x in the denominator. Again, we're going to multiply top and bottom by the conjugate, which means that we're going to leave every term the same, but instead of the subtraction that we have here, we're going to put an addition. So let's do our multiplication here and see what happens. We're going to do, again, a FOIL method. So we're going to do first times first is going to be 25. Do our outside terms will be 5 on the square root of x. Our inside terms, multiplying those two together, will be negative 5 on the square root of x. And our last terms will be minus the square root of x squared. And on the top, we're going to have a negative square root of 5x times, in parentheses, 5 plus the square root of x. So again, let's look at simplifying this. I'm going to leave the top alone for right now. And the denominator is going to be written 25. These middle terms will cancel out. And we're going to have minus x. So in actuality, we can leave our final answer like this. Or you may see this actual term on the top distributed. So that's another possibility. You could write it negative 5 times the square root of 5x. Minus the square root of 5x squared over 25 minus x. And in doing this, you actually have now the option of taking the square root of this x squared. So you can simplify just a little bit further going in this direction. First term is going to stay the same. The square root of 5 I cannot do, but the square root of x squared becomes an x. And so we'll have 25 minus x in the denominator. So in actuality, this is probably a more simplified example than what we had up here. Okay, moving on. Our next topic involves combining radical expressions and trying to simplify those. So let's look at a few examples of this. You are able to combine radical expressions if you have the same exact term underneath the square root. So as it stands right now, these two are not like terms because one of them has a square root of 8x to the 5th. And one of them has a square root of 18x. And so they are not going to be considered like terms. So we want to look at whether or not it's possible to get them to the point where we can combine. So let's look at simplifying these things. So this first one, negative 3 times the square root of 8x to the 5th. Let's try to rewrite this. Since we know we're dealing with a square root, let's rewrite this in terms of groups of 2. So I can rewrite the 8 as 4 times 2. And the x to the 5th, I'm going to write x squared, and x to the 1st. Still maintains the 5 x's, it just writes them in a different format. So let's look at what that does for me now. If I take the square root of each of these separately, the square root of 4 is 2. And it's going to come out to the front. The square root of 2 cannot be done, so I'll leave it underneath. The square root of x squared becomes an x. The square root of another x squared also becomes an x. And the square root of x to the 1st stays as an x. So let's look at what we have here. We have a negative 6 and 2 x's. That's going to make x squared. on the square root of 2x. All right, so let's look at the 18x underneath the square root. I'm going to do the same thing. I'm going to write 18 as 9 times 2 and the x as an x. And we are taking the square root here as well. So the square root of 9 would be 3. The square root of 2 cannot be done, so it stays underneath. The square root of x to the first remains x. All right, so look at what we have here. We have these two terms that are added together. So I have negative 6x squared on the square root of 2x plus 3 on the square root of 2x. And now they are like terms because they both have a radical 2x. So what we can do is we can essentially factor this square root of 2x out of both terms. So if I take the square root out of this term, that's going to leave me negative 6x squared. And I've got a plus in between. And if I take the square root of 2x out of this term, that's going to leave me a 3. And so this will be our final answer for this problem. Let's look at part B. Okay, for part B, we need to do the same sort of thing, but this time we are working with the cubed root on the first problem. So we have a cubed root of 54x to the third. Let's rewrite the 54 in terms of numbers that would have a cubed root. So 54 could be 27 times 2, and then we have an x cubed. So the cubed root of 27 is 3. 3 times 3 times 3 is 27. The cubed root of 2 cannot be done. The cubed root of x to the third is x. All right, let's look at the square root of 50x squared. So on the 50, let's write it as something that is a perfect square. So 25 times 2 times x squared. So the square root of 25 is going to be 5. The square root of 2 cannot be done. The square root of x squared, because we're dealing with an even power on an x underneath the square root, we know that that will need to stay in absolute values. And so we're going to put our two expressions together with a plus. So I have 3x times the cubed root of 2 plus 5 times the absolute value of x on the square root of 2. And we can leave our final answer that way. Okay, and we cannot combine these radicals because they are not exact terms. This is a cubed root and this is a square root. All right, so let's look at part C, the last part for this problem. We have 1 over 12 underneath the radical minus the square root of 25 over 48. And again, we want to try to simplify them so that they have like terms and can be combined. So let's take the square root of 1/12. We want to write these as perfect squares if possible. So let's write it as 4 times 3. I know that I can break it up. So the square root of 1 is 1. The square root of 4 is 2. The square root of 3 cannot be done. All right, so let's look at the other one. The other one is 25 over 48. So let's rewrite. The 25 is a perfect square, so I'm going to leave that alone. The 48, let's write as 16 times 3. And we'll break it up. Radical of the top, radical of the bottom. The square root of 25 is 5. The square root of 16 is 4, and the square root of 3 cannot be done. So now what we want to do is we want to get these in simplified form, which means that we want a radical out of the denominator, and then we want to hopefully see if we can combine our terms. So let's multiply both of them by the square root of 3. That will rationalize our denominators. So on the top one we have the square root of 3 over 2 times square root of 3 times the square root of 3 is 3. So we have the square root of 3 over 6. On this one we're going to have 5 on the square root of 3 over 4 times 3. So that's going to give me 5 on the square root of 3 over 12. And we want to subtract these two terms. So we have the square root of 3 over 6 minus 5 on the square root of 3 over 12. And we know that in order to subtract these fractions, we have to have like denominators. So we need both of the denominators to be at 12. So I am going to multiply these two terms by 2. So our first expression becomes 2 on the square root of 3 over 12 minus 5 on the square root of 3 over 12. And when we subtract, 2 minus 5 is negative 3 on the square root of 3 over 12, which we can finally reduce this part to negative 1/4. And then we'll have our square root of 3. And so that is the answer to that problem.